Hello, Assalamualaikum warahmatullahi wabarakatuh, and good day to every one of you. Okay, so in this lesson, we will discuss on the methods on how to solve second order non-homogeneous linear differential equation with constant coefficient. So first of all, before we go any further, before we go through what are the methods that we are going to be used, so we need to understand first the term. What does it mean by non-homogeneous? What does it mean by linear differential equation? And what does it mean by constant coefficient? Okay, so let's say you are given a second order differential equation in the form such as this. Okay, whereby you have a y double prime x plus b y prime x plus c y x equal to fx. Okay, take note that the power for y double prime x and the power for y prime x, the power for yx are equal to 1. So, in this situation, the second order differential equation is called as a second order linear differential equation. Okay, if a, b, and c are a constant value, then the differential equation we call as a differential equation with constant coefficient. Okay, the last part will be for the fx. Okay, have a look at the fx. If the fx is equal to 0, so the whole equation we call it as a homogeneous linear differential equation with constant coefficient. But if the fx is not equal to 0, let's say the fx is a trigonometry function, or maybe a polynomial function, or maybe exponential function, so the whole equation we call as a second order non-homogeneous linear differential equation with constant coefficient. Okay, so in order to solve the second order non-homogeneous linear differential equation with constant coefficient, so we are going to use the methods of undetermined coefficient. So basically there are two different types of how to solve the equation. So the first one is the method of undetermined coefficient, this method, and the other one is the variation of parameter. But in this lesson, we are trying to cover only this method. Okay, so in order to use this method, what are the procedure that we need to be used? Okay, so the first method, the first procedure, the first step is you need to find the YC. YC we call as a complementary function. Okay, then after you find YC, you need to find the YP, particular integral. Okay, so later on we will see what is YC and YP actually. Okay, the third step, once you find your YC and YP, you can find your general solution of the ODE. So your general solution Y is equal to YC plus YP. Okay, and then the last part will be you need to consider the initial conditions if applicable. So it means that, let's say like the question are asking you find the general solution for the ODE, so you need to go until step number 3 only. Let's say the question asking you find the particular solution, so you know the question giving you the initial condition, so you need to consider the initial condition as well. Okay, alright, so how to find YC? So YC is basically same as in solving homogeneous equation, just like what you learned in the previous video. Okay, so don't worry, later on we will see in detail when we do exercise. Alright, so how to find YP? YP is determined based on type of fx. Okay, type of fx. If you still remember just now in the previous slide, I did mention that fx can be trigonometry function, it can be polynomial function, or it also can be exponential function, right? So based on the type of fx, we can determine the YP. Okay. Alright, so what are the steps in finding the particular integral? Alright, so the first step, okay, again, like I mentioned, you need to assume the YP based on type of fx. Okay, so how to assume this? Basically, you are provided with a table. So based on the table, you can determine your YP. Alright, so once you assume your YP, you need to check if the YP have same pattern with YC. Okay, if yes, you need to multiply the YP with X. Okay, and then you check again. If it still have same pattern, you still need to multiply with X over and over again until the pattern is not the same. Alright, okay. Let's say if YP not same, so you can proceed to step number 3. You need to find the YP prime and YP double prime. Okay, the last step, you need to substitute the YP prime and YP double prime into the given DE and then obtain the value of the constant DE, etc. by equating the coefficient. Okay, so later we will see in details on these steps when doing the exercise. Okay, so how to assume the YP based on type of fx? Okay, so how to assume the YP actually? Alright. So, in order to assume the YP, we assume based on the type of fx as shown in this following table. Alright. So, let's say your fx is an exponential type. So, example, your fx equal to k, e, and x. So, you assume your YP is equal to c, e, and x. Okay, for polynomial type, let's say your fx is equal to k, so your YP is equal to c. If your fx is equal to kx, then your YP is equal to cx plus d. If your fx equal to kx squared, then your YP is assumed to be cx squared plus dx plus e and so on. For trigonometry case, we will only cover for sine and cos only. Okay, let's say your fx is equal to k sine and x, or your fx is equal to k cos and x. So in these cases, you assume your YP is equal to c cos and x plus d sine and x. Okay, so let's say if your fx is equal to k shin and x or k cos and x, so then your YP is equal to c cos and x plus d shin and x. Okay, so let's have a look at the following example in which the fx consists of exponent function. Alright, so the question will be, find the general solution for y double prime minus 6y prime plus 9y equal to negative 2 exponential 3x. Alright, so step number 1, you need to find the complementary function yc. Okay, so basically, this complementary function is a corresponding solution for the homogeneous equation. Alright, so from here, this equation is a non-homogeneous, right? So make it homogeneous by replacing the function with equal to 0. So for this homogeneous equation, you come out with the characteristic equation. So the characteristic equation will be m squared minus 6m plus 9 equal to 0. So based on this quadratic equation, you try to solve it using your calculator and then to find the root number. So the root number is equal to m1 equal to m2 equal to 3. Okay, so this is case number 2 where your solution for the homogeneous equation is equal to a plus bx multiplied with exponential mx. So this m value represent the root number. So again, those we know that yc, the complementary function, is equal to a plus bx multiplied with exponential 3x. Okay, so you can expand your equation so that you can get yc is equal to a e3x plus bx e3x. Okay, so next we go to step number 2. Step number 2, you need to find the particular integral, yp. So this yp, we assume based on the type of the function fx. So you refer to the function of fx. Fx is equal to negative 2 exponential 3x, right? From here, your fx is equal to negative 2 exponential 3x. So this is exponent. So it belongs to the case number 1. So you just refer to the table. If the fx is equal to k exponential and x, so you can assume your yp is equal to c exponential and x. So in this case, this n value is equal to 3. Okay, so you get your yp is equal to c exponential 3x. Okay, and then you need to compare this YP to the YC. Okay, so you compare here, you have C exponential 3x. Here you have A exponential 3x. So we assume it has a same pattern. So we consider it equal to YC. So when it have same pattern, so you need to multiply this with x. So you get YP equal to CX exponential 3x. Again, you compare to the YC. So have a look. CX exponential 3x is equal to BX exponential 3x. So it still have the same pattern. So again, you need to multiply with x. So CX squared exponential 3x, you compare back to here. So it does not have the same pattern, right? So you can stop here. Okay, so basically this is the final YP that you are going to use throughout the process. Okay, so now your YP is equal to CX squared exponential 3x. Okay, so at this stage, we are trying to find what is the value for C. Okay, so in order to do that, you need to differentiate YP. So from YP, you differentiate, you get YP prime. Okay, so how to differentiate this? You can use product rule, U dv dx plus V du dx. So in this case, you assume your U is exponential 3x, your V is CX squared, so your dv per dx is 2CX plus V du dx, so this is your U du dx is 3 exponential 3x CX squared. Okay, so from there, you further simplify the equation. By factorizing the exponential 3x to the outside, you get this equation. Okay, so and then after that, you need to find the YP double prime. So again, you use the product rule to differentiate this equation. So from here, you differentiate 3CX squared, you get 6CX. You differentiate 2CX, you get 2C. And then you differentiate exponential 3x, you get 3 exponential 3x. Okay, so again, from there, you can further simplify it by factorizing the exponential 3x to the outside. 6CX, 6CX, 2C, 2C. And then 3 multiply 3, you get 9CX squared. 3 multiply with 2, you get 6CX. Okay, from there, you further simplify the equation by getting 9CX squared, 6CX plus 6CX, you get 12CX plus 2C. Okay. Next, once you get your YP, YP prime, and YP double prime, you can substitute all these three numbers into the given ODE. Okay, based on the question, the ODE is given by y double prime minus 6y prime plus 9y equal to negative 2 exponential 3x. Right? So from there, you can get YP double prime minus 6YP prime plus 9YP equal to negative 2 exponential 3x. Okay, so then you substitute your YP prime and then your, YP double prime, YP prime and YP you substitute. And then after that, you need to rearrange it according to the, you need to rearrange accordingly. Okay, so here I got exponential 3xx squared, exponential 3xx, and exponential 3x. So 9c plus 6 multiplied with 3. So I get 9c minus 18c plus 9c. This one I can cancel it, become 0. And then 12c minus 12c, I still can cancel, become 0. And here, exponential 3x to c. So, and then after that, I can equating the coefficient. So, exponential 3x, exponential 3x. So, 2c equal to negative 2. So, I get c is equal to negative 1. Okay, so, yp is equal to cx squared exponential 3x. Substitute the value for c. So, now I get negative x squared exponential 3x. Okay, so now I got my yp. So, the last step, I need to find the general solution for the ODE. So, general solution is given by y equal to yc plus yp. So, here is my yc. And then here is my yp. Okay, so that is the step-by-step on how to get the solution for the ODE. Okay, so thanks for watching.